Hello and welcome to your presentation on margin of safety and minimum sales point. So these are going to be two different approaches in which we use our costs to then either find out more information or some of this information will actually even help us make some decisions. So the margin of safety really shows how close a projected amount of sales is to your break even. So it does exactly what it says it does. It's going to show you how close you are to breaking even based on what you're projecting you're going to do in your sales. So the lower your margin of safety, the higher the chance that you may actually experience a loss. What you're looking for is hopefully a bigger margin of safety. That means that you are further away from your break-even point. So if we take a look at an example here, we have our projected sales for Emma's restaurant for December. Projected sales of $150,000, and that represents about 11,253 guests. Break-even sales are $100,000 and 7,500 guests is the break-even units. So what's our margin of safety? Well, it would simply be our projected sales minus our break-even sales. So for the whole month we have $50,000 margin of safety. That means that based on what we believe we're going to do in sales, we're $50,000 above our break-even point. So that's our margin of safety. That's a pretty good one. Okay? And then for our guests, we would do the exact same thing, and we would simply subtract one from the other. So 11,253 guests, forecasted guests, minus the break-even units, which is 7,500, and that would mean that we have 3,753. So that's a pretty big margin. Okay, that's giving us the fact that we could lose 3,753 guests, and that would just bring us to just the break-even point. So we wouldn't even be experiencing a loss yet. That's great. I'd be very happy with that. What we could also do is we could break it down per day so that every single day we know how we're doing. So we could go $50,000 and then divide it by, in this case it's December, which has 31 days. So we would have a margin of $1,612.90 every single day. So that's just in sales. So as long as I stick with my projections, I've got about $1,600 to play with every day before I break even. Okay, so this is also good. And then if we take a look at our guests, we would then discover that 3,753 divided by 31 days, that means 121.06 guests per day. So we're doing pretty well here. We're laughing. Now, one thing that you have to remember is that we always need to round down this margin of safety per day for our covers. Now, the reason why we do this is because a fraction of a guest does not exist. And we're trying to give ourselves a more realistic. We're understating how many guests we have as a margin of safety. So once you've set the margin of safety for the month, it can be divided by the number of days in the month to show the margin of safety per day. We've already done that. We're always going to round the number of guests for margin safety down because it doesn't exist as a fraction, as I just said. And it's better to understate it so that you have more of a safety. So once the number of guests is rounded down, managers are usually going to adjust that margin of safety, okay, so that it reflects the reduction. Okay. The difference, especially in this example, could be minimal. You may not even want to do this, but it's still a good practice to continue to do it because when the difference isn't so small, you'll, in as far as the rounding down, you will see a bigger difference in the sales. So again, let's take a look at this. To find this information out, we need an average check. Okay? We need to be able to discover an average check. So in this case, we could either do break-even divided by guests or projected divided by guests. Okay? So in this case, I would probably do my projected sales. I'll use my projected sales. 150,000 divided by the 253. So if we do that, divided by 11,253 forecasted guests, $13.33. So $13.33 is my average check. Now my adjusted margin of safety per day is 121. We're no longer at 121.06. We've rounded down. So now if I want to know my adjusted margin of safety per day, I'm simply taking my guests that I'm now serving, my margin of safety of covers per day, times that average check. So 121 times 1333. 1,612 and 93 cents. Oops, my apologies. 1,612 and 93 cents. Now in this case we're talking about rounding down from 121.06, which is extremely close already, to 121. So we see a minor difference here. It's not even worth it, right? When this number becomes 121.93 and we round down to 121 and we start talking about numbers bigger than this, it does make a big difference, and it's definitely worthwhile to complete an adjustment here. So that's going to be for our margin of safety. Again, we're just going to see how close we are to breaking even. Now if these numbers start to be very close, so if this number, all of a sudden this margin of safety was $10,000 and we're $10,000 for the month as far as a margin of safety goes, which means we're only projected to make $10,000 more than my break-even sales, then I have to be quite careful. I have to be very concerned, and I may want to actually step up my marketing. Okay? I may want to try and figure out how am I going to change these projected sales so that I have a bigger margin of safety. Okay? Now, for minimum sales point, it's a bit different. It's really the dollar volume and dollar sales volume required to justify staying open for a given period of time. If you remember in class when we did our bottom-up approach, we looked at a restaurant for the average check, and they were open 6 days a week. And we talked about how could you make more money? Well, they could open up an extra day. But would they make more money? And this minimum sales point really helps us find out a bit more information about whether or not we should be open earlier. If we're only open for lunch and dinner, we could open for breakfast. If we're only open at noon, maybe we can open at 11. It could also help us decide if we can stay open later. So if we're open until 11, but we feel like we could have enough business from 11 to 12, how much do we need in sales in order to actually make enough, to actually make it worthwhile? And then also, should we open an extra day a week? So the information that we definitely need to have is food cost percentage, minimum payroll cost for the time period, and then variable cost percentage. Okay? We don't talk about fixed costs because even if the sales volume is 0 or $1 million, fixed costs still exist and they have to be paid, right? So we're less concerned about them, and we're more concerned about our variable costs, which are our food costs, our other variable costs, and our minimum payroll costs for the time period. So the calculation, okay, we are dividing the minimum labor cost by 1 minus the minimum operating cost. Minimum operating cost is simply for a restaurant food cost percentage and variable cost percentage. That's the minimum because it's what we actually need to operate. Okay? So minimum operating cost could also be food cost percentage plus variable cost percentage equals our minimum sales point. So let's go to an example. Okay? Where you own a restaurant and you're thinking about opening for breakfast. So it's a 3-hour meal period. Your sales are, sales last year were $1.5 million. Okay, well, excuse this. So, 1,500,000. From your income statement, you're able to figure out that your total cost of sales last year was, and we'll call that product cost percentage, was 480,000. And that your other variable costs were 55,000. The cost of staffing your restaurant would be an extra $250 per hour. Okay, and we said that it's going to be 3 hours. So, variable costs. Now what we want to do is, if we remember, and we can go back and to make things even easier, we'll bring this over here. Okay, we need to discover our minimum labor cost divided by 1 minus food cost percentage plus variable cost percentage. So notice how food cost percent and variable cost percent, it's percentages. We only have total amounts. Last year's sales, 1.5 million. Think back to common size analysis. Sales are always going to be our 100%. Therefore, if we want to find out our variable cost percentage, we can go our variable costs divided by our sales. And one more zero, there you go. So 30%. So our variable costs are 30%. Oh, 30.33, perfect. Our product cost is going to be the same, 480,000 divided by 1.5 million. And we'll turn that into a percentage. So 32%. Okay. So our minimum labor cost, it's 250 per hour, but we're talking about 3 hours. So 3 times 250. So for the 3 hours, it's going to cost us $750 in labor cost. So now we can actually do the math. So we can go our minimum labor cost, which is $750, divided by 1 minus, and this is where food cost percent, okay, which in this case is our product cost percent, is 0.32 because we're turning it into a number. Okay. Plus, and I put it, my apologies. I'll start that over again. I hit the wrong button, sorry. So 750 divided by, and we're going to go our 1 minus, and then we're going to add our food costs, so 0.32 to our variable costs. Okay. And this is what it would look like. So 750 divided by, and then we have to make sure we're using bed mass, so 1 minus whatever the total of our variable costs are. Okay. So our food cost percentage and our variable cost percentage. So that means that we need to make $1,990.97 over the course of those 3 hours in order for it to make sense. So we would then want to forecast at that point and see whether or not for the 3 hours of breakfast we can make that amount of money. And that's basically what we're doing. We're trying to figure out, if we stay open for 3 extra hours, we have to pay $750 in labor. That's going to be our kitchen staff, our extra servers, a manager to work. Okay. We have variable costs which are going to fluctuate with sales, okay, and that's going to be our food costs and any other variable costs that are important. So if we take all of those into account, okay, we need to make this much money in order to just cover, and that would just be to cover our costs. Okay. So we would be hoping that for that 3 hours that we would start to be open, that we would make at least $1,990.97. And if we don't believe that we can reach these sales in these 3 hours, then we shouldn't stay open. We shouldn't even open because we'll be experiencing a loss. If we forecast that we could make more than this minimum sales point over 3 hours, then it's probably makes sense, and I would actually be adding money to the bottom line. Anything above this really would be good because you'd be adding something to the bottom line. So that's your presentation on margin of safety and minimum sales point.